Isaac Newton was an English philosopher and a scientist. He was born in 1963 and was part of the scientific revolution. He's very famous for contributing in optics, motion, maths, and physics. Especially, we're going to focus on physics in his contributions, especially on the laws of motion. But he also contributed in the theory of gravity, which is what he's more famous for, and in his book, The Mathematical Principles of Natural Philosophy.
Motion, also known as the law of inertia, says that an object in rest stays in rest and an object in motion stays in motion with the same direction and acceleration unless an unbalanced force is acted upon it. When the ball is in rest, the vectors are the same. But then, when Sofia kicks it and the force is acting upon it and it moves, the vectors change. And this vector increases and this vector increases because this is the direction it's traveling in and this is the acceleration. So then, when the ball hits the net and another force with the same force is created, this vector stays the same and this vector stays the same. Well, this vector increases to stop the ball. Lastly, when the ball hits the net and equal vector is created towards the left than the one that was already towards the right, and the vector that is pointing upwards disappears because the ball is slowed down and it goes down, so this vector increases. And so the ball goes down, down until it reaches a point in rest again, and the vectors stay the same as they were in here, and they add to 0.
Newton's second law states that if you exert the same net force into two different objects of different mass, the acceleration will be different. And for this law, we use this formula. Acceleration equals net force over mass.
Your mom?
Like we said before, on the second law, we're going to focus on F equals mass times acceleration. But this time, we're going to focus specifically on acceleration and how it equals force over mass. As you saw in the video, there was a table, an example of me pushing the table and then pushing the book. When I was pushing the table, you can tell that because the mass was bigger, the acceleration was smaller. So therefore, but the force remained the same. In the example of the book, it had a smaller mass, the force was the same, but as a consequence of these factors, the acceleration was way bigger, and it was pushed further away. In the example of the book, there's a vector that's going up and an equal vector that's going down. That's due to gravity and friction. Now I implement force straight up, which is way bigger than the force that is being pushed back on because of friction. As an effect, the resultant vector makes it go straight up with a lot of acceleration. Meanwhile, in the example of the table, I implement the same force, but because the vectors that go up and down due to gravity are way bigger they cause our vector that goes in the opposite direction to also be great. And as an effect, the resultant is small, therefore it doesn't have such a great acceleration. And this is caused because it has a bigger weight, the table has a bigger weight. Okay.
The third law of motion says that for every action there is an equal and opposite reaction.
Of the third law of motion, you guys saw the balloon which hits my face. And this is caused because of two vectors or two forces that are equal and opposite. You can see one goes up and another one goes down. And this caused the balloon to fly up straight into my face.
And I thank you for it. Alright.
We'll figure it out.